Hi, my name is Jyoth Kohli, and today we're going to go over Introduction to Equilibrium Reactions. What is chemical equilibrium? So, chemical equilibrium occurs when the rates of the forward and reverse reactions are equal, resulting in no net change in the concentration of reactants and products. The concentrations or partial pressures of all species remain constant. Dynamic equilibrium. The reaction still occurs, but there is no observable change in the amount of products and reactants. Forward and reverse reactions. In a chemical reaction, the forward reaction refers to the reaction as it progresses from reactants to products, while the reverse reaction refers to the reaction as it progresses from products back to reactants. So here we have a reaction, A plus B turns into C plus D, and the forward reaction is the same, A plus B turns into C plus D. This shows how the reactants A and B are transformed into the products, C and D. And now, a reverse reaction is a reaction in the opposite direction, where the products are converted back into reactants, sorry. And so if we use the same example as above, the reverse reaction would now be the opposite. C plus B turns into A plus B. And this shows how the products C and D react to form the original reactants, A and B. Equilibrium graphs. So graphs of concentration, partial pressure, or rate of reaction versus time for simple chemical reactions can be used to understand the establishment of chemical equilibrium. So here we have a graph that shows pressure and time, and as you can see from 60 seconds onward, the partial pressure of the reactants and the partial pressure of the products are constant over time. Therefore, from 60 seconds onwards, the graph is at chemical equilibrium. Now here we have a practice problem. So sulfur dioxide and oxygen gases were placed in a rigid vessel and allowed to reach equilibrium in the presence of a catalyst. The diagram below shows how the concentration of SO2, O2, and SO3 in the system changed over time. Based on the graph, which of these claims is most likely correct? So here we go. Option A, the reaction reached equilibrium between A and B because the concentrations of SO2 and O2 were equal. And this is wrong. The reaction has not yet reached equilibrium between A and B, and although the lines are parallel, it does not mean that they have reached equilibrium. And also the concentrations of SO2 and O2 are not equal. As you can see, the line SO2 is above the line O2, so their concentrations are not equal. And a third thing that's wrong with this is that they don't have to be equal for us to have reached chemical equilibrium. So option A is out. Option B, the reaction reached equilibrium at time B because the concentration of SO2, O2, and SO3 stopped changing. So this seems right. As you can see from time B, the concentrations of all three have stopped changing and are constant over time. So option B seems right. Let's move on. Option C, the reaction reached equilibrium at time C because the reaction stopped consuming SO2 and O2. Okay, the reaction has not stopped. So when chemical equilibrium is established, it might look to our eyes that the reaction has stopped happening, but it is still actively happening. The forward reaction is happening, the reverse reaction is happening, and there's a lot going on behind the scenes. So the reaction has not stopped, and so that's why option C is out. And option D says that the reaction has never reached equilibrium because not all of the SO2 and O2 was consumed at time B. And we know that the reaction has reached equilibrium, so it's already wrong. And also, the reactants don't have to be completely consumed to have reached equilibrium. So that's also another reason why option D is out. So option B is the right answer. Thanks.